I'm Andrew Culham with Shibogama Technical Services. I'm a housing and building inspector for 5 remote First Nation communities in Northern Ontario. I'm based out of Sioux Lookout, and today I'm here to talk to you about roof flashings and valleys. So it's an important part of the roof is making sure that you direct water away from any intersecting planes that you might have. You might have chimneys or other vertical surfaces that butt up against your roof line. So I put together a PowerPoint presentation, and if I can get Chris to put on the first few here, and we can get going on learning all about different parts of the roof. So I kind of explained already about the roof valleys and flashings and how important they are. Basically, a flashing is a thin piece of metal. A lot of times it's galvanized so it doesn't corrode and rot over time, because they're meant to be there for a long time, sometimes even longer than your shingles. They get reused when you re-roof a roof sometimes, depending on if they're in good condition. There's a lot of different areas that they can be used in. If we could move on to maybe the next slide there. Yeah, so basically it's just kind of going over what I've already said. The roof flashing is thin material, galvanized steel. Basically it's just you're directing the water away from any of these intersecting points in the roof. So a chimney, roof vents, and things like that stick out of the roof that you don't want water to run into. If we can go to the next slide there, Chris. So here's a picture of what can happen if you don't have the flashings installed properly. What's missing on this one, from what I can tell, is the kickout flashing at the bottom of that roof line there is missing. So the water is just flowing right in behind the siding and created a large amount of damage. And sometimes it's hard to see until it's already too late and it's created the damage. So we'll get into more points on how to do a kickout, or what a kickout is, and some of the little tricks that you can do to prevent damage like this. We can go to the next slide there. And then there's other things like this here. This is actually a chimney, and depending on where you are in Canada, these can be seen all over the place, where you have an actual enclosed chimney for a wood stove or a gas furnace or even an oil furnace. But what's missing here is what I call a cricket or a saddle. So that it diverts the water away from flowing straight into a wall like this. There might be a flashing on there, but it's not installed properly, and that could create a pretty big issue later on down the road. All right, we'll go to the next slide here. So what is roof flashing? How do you install roof flashing? What about repairing roof flashing? What other products can help with flashings? Because with a roof, it's a multi-layered system. It's not just the metal flashing. There's other products that are out there to aid in your making sure that your roof is watertight as it can be. Just go on to the next one there. Maybe the next one. So these are the different types of flashings that are the names that we use when we're talking about flashing. So we've got a continuous flashing, a base flashing, a counter flashing, step flashing, valley flashings, kickout flashings, and then there's a number of specialty flashings that I've got listed at the end of the slides here with some pictures to help kind of explain exactly what they are. We can go to the next one. So right here is a continuous flashing. What this is here is it's running all the way along a wall that would be butted up against your roof. And so that's one continuous piece. Sometimes it has to be two pieces if it's a really long wall. That allows, it directs the water away. So the water will hit the siding, hits the flashing, and then goes down the roof, and that's what it's all about. The only thing I see missing in this picture is the nails there are not covered, and that's a really important part of making sure it's sealed properly is covering up those nails with a roofing cement, something that's designed for the roof. Sorry, I'm being told to do my own slides. I think I figured it out. My picture here was in the way. Let's see if this works. Just making sure I'm pushing the right button. I'll get us into the next one here. Maybe Chris can come on for a second and just tell me exactly where to. There we go. Okay, so base flashing. So on the bottom side of a chimney, if your chimney is coming through the middle of your house, is important. It directs the water away from water hitting your chimney. This is sometimes made on site, depending on the size of the chimney. And you see the picture there, I've got counter flashing. I'll talk to you about that on the next slide there. And the counter flashing, it's kind of like a slip joint, because depending on the type of chimney you have, if you're in part of Canada that has a masonry chimney and it's not necessarily attached to the wood framing because you need certain clearances for fire protection. So what you're going to have is you're going to have a flashing that goes over top of that, and that can actually move around with the different temperature changes. And if you have more snow on your roof, it can actually prevent that from failing over time. Sorry, Chris, I can't figure out where the button is to advance it. I'm not sure if my screen's different. We'll go to the counter flashing here. Yeah, so we talked about that. And you can see how even it runs up the side of the house. It would kind of continue all the way around the whole chimney. If this was built out of wood or if it was sided, you could put a blue skin, and a blue skin can kind of act like a counter flashing behind your siding, your vinyl siding or wood siding, or any kind of siding you have on a wood framed chimney it would act as a counter flashing as well, because it would go over top of your base flashing or your step flashing. So this is your step flashing. It as you can see, it's a 90-degree piece of metal that's bent that runs up along and kind of woven in with your shingles to direct the water away from an intersecting roof line or a wall. And at the bottom there, we talk about kickout flashings as well. That's a little bend there that stops it from running down in behind the wall or in behind the siding. And that first picture I showed you where all that rot damage was, I'm assuming that's what was missing from that was kickout flashing, and all the water that was directed to the step flashing ended up just running in behind the wall and creating a tremendous amount of rot. And then you can kind of see that peel and stick membrane. That's kind of what I was talking about, is counter flashing, and that seals the step flashing to your wall, and then your sheathing or your air barrier would sit on top of that. So it kind of just helps shed all the water away from the building. So if you have water hitting the siding, and if it gets in behind your vinyl siding has little drip holes. So sometimes, depending on how the water hits it, it can actually get in behind, and it will still run down on top of your roof and not get in behind flashing. I think the next slide talks about the kickout. Yeah, so there's a little bit of a better picture of the kickout flashing. Just a little better picture there, a different picture that shows how it pushes the water away from the edge of the roof. I have a video here too of explaining how to install roof flashing.
Roof planes that butt against vertical walls at the end of the shingle course are protected by a metal step flashing at least 5 inches high and 5 inches wide. When applying the new shingles, each shingle course will be covered by a step flashing. There are 2 simple rules to follow. Each flashing should overlap the one below by at least 3 inches, but not be visible below the shingle top lap. Embed each step flashing in a 3-inch wide application of asphalt plastic cement and nail in place. Then the end of each shingle overlapping a step flashing must also be well embedded in plastic cement. The metal step flashing shingles are rectangular in shape and style, approximately 10 inches long and at least 2 inches wider than the face of the shingle being used. For instance, when using metal flashing shingles with a typical 5 5/8 inch exposure, the size of the flashing will be 10 inches by 8 inches. The 10-inch length is bent in half so that 5 inches will reach up the wall surface and the other 5 inches will extend onto the roof deck. Note, other step flashing sizes are also acceptable. To install the flashing shingle on the first course, place it over the end of the starter strip. Place it so the tab of the end shingle covers it completely. Secure the horizontal flange to the roof deck using 2 nails. Do not fasten the flashing shingle to the vertical wall. This will allow the flashing shingle to move with any expansion and contraction that may occur with the roof deck. Place the second step flashing shingle over the end shingle in the first course by positioning it 5 5/8 inches above the bottom edge of the exposed asphalt shingle. Make sure that the tab of the shingle in the second course will cover it completely. Secure the horizontal flange to the roof. The second and succeeding courses will follow, with the end shingles flashed as in preceding courses. Chimney flashings are secured to the roof over top of the shingles, and counter or cap flashings are secured to the chimney, providing a waterproof seal. For pipe flashings around soil stacks, shingle up to the bottom of the stack. Apply plastic cement around the edges, and then slide the new flashing over the soil pipe and into place. Nails used to secure flashings to the roof should be used sparingly, not be driven close to the pipe, and where recommended by the manufacturer. Continue shingling, cutting to fit around the stack. Each cut shingle should be laid in a bead of cement. A dab of plastic cement over the exposed nails is recommended to avoid leakage.
Yeah, so in that video, it was pretty good. They explained how anytime you do anything with a certain type of product, you want to make sure that you read the instructions on the actual package. And I know it's usually the thing that gets tossed first, but if you want to make sure that roof lasts and doesn't have any issues later on, it's really important to read that, because they're going to have some steps that you need to follow to ensure that if there's a warranty, that it can be you're doing everything you can to make sure that you've installed it properly. So if you do have any issues, that it can be replaced, hopefully under warranty. Right, next we'll go on to valley flashing. So there's 2 different types of valley flashing. Oh, I got a cat who decided to climb up into a cabinet. We've got open valleys and closed valleys. And the closed valleys, there's actually 2 different types you can do here. This one is cut on a nice straight line. It looks more aesthetically pleasing to me, or at least my opinion is it looks nicer that way. You can also weave it as well. I just find sometimes the shingles get a little thick in that corner, but that's a personal opinion. I know the manufacturers like to have an open valley. You can see it. You can see exactly how it's been done. It's cemented together, and you're relying on a continuous piece or a couple pieces of metal to make that work. Again, you have to follow what the manufacturer tells you on a few different things. You'll have an ice and water shield underneath either of the applications, and they're going to tell you where to nail and where not to nail, because you don't want to be putting any more nails in the middle of a valley. It's a weak point in the roof, and if you put nails, you're adding another hole. So that's just something you want to make sure you follow. I do have a video here as well to kind of explain. There's a couple pictures here, more details, and in this is one manufacturer's suggestion. And if you see on the top, you'll see it in the video as well. They actually cut back the shingle on an angle, and all that's the reason they do that is to, if water gets underneath there, if you have a slight ice dam, it's going to direct the water down the valley. And it's just an added assurance that it's not going to get underneath the roof and create issues for you later on. And then I've got another quick picture here of a closed valley. So basically, rather than a metal flashing, you're using your shingles as your flashing, and then cutting a straight line, or you're weaving them together. But when you weave them together, you're not going to be putting nails in the actual valley itself. You have to keep your nails away from the valley. And next here, I've got a video of how to shingle a valley.
There are several different valley application methods, which include closed, open, and woven. For longer roof performance, ICO strongly recommends open metal valleys. Complete the application of underlayment and valley flashing before the shingles are applied. The recommended flashing material is a 28-gauge galvanized metal or an equivalent corrosion-resistant, non-staining material. Check with local codes. Center a 36-inch width strip of an ice and water protector membrane in the valley. The product is tacked and placed temporarily along one edge. Carefully peel away the backing and put it in place, smoothing out any wrinkles. Start working from the eave, allowing additional pieces to overlap by at least 6 inches. Remove the temporary nails. Center a minimum 24-inch wide, minimum 28-gauge pre-finished galvanized metal valley liner in the valley and fasten with only enough nails to hold it in place, nailing at the edges only. Overlap each metal piece by at least 6 inches and use asphalt plastic cement under each section of overlap. Snap 2 chalk lines at the full length of the valley, 6 inches apart at the top, 3 inches on each side of the valley, and increasing in width 1/8 inch per 12 inches towards the bottom to a maximum of 8 inches. When the shingles are being applied, lay them over the valley flashing, trim the ends to the chalk line, and nail the shingles at least 2 inches back from the chalk line. Cut a 2-inch triangle off the top corner to direct water into the valley and embed the valley end of each shingle into a 3-inch band of asphalt plastic cement.
Follow the directions. The other thing you want to make sure too is if depending on where you are in Canada, you want to just check with your building codes, because they might have different specifications for wind and snow and rain. I know some parts of Canada have sideways rain as well as coming straight down. So you just want to make sure that if you're needing to do any extra sealing and things like that around a valley or anything, that you do that. I know you can also add more ice and water shield depending on how many freeze thaw cycles you have in your area as well. So just another good thing to check with if you have a tribal council and you have housing advisors or building officials that you can talk to just make sure you're doing the best you can to keep the water out of the building. So the next thing we're going to talk about is drip edges and rake edges. So your drip edge is along the bottom edge of your roof. And all that does is it directs the water away from your fascia and protects the fascia board. And then the raker does the same thing, but it does a couple things. It gives the edge of your shingle a bit of support, and it also helps with any kind of water that could get onto it. It helps direct it away from the eave. And it also allows, when you have an aluminum fascia, you nail them behind that and it covers up the nails and kind of keeps that tight. You get some pretty crazy winds in Canada here. So the more you can do to protect those layers and keep them in place, the better. So And then if you look at the bottom of that picture there, it's got a bit of a bend on it. And the reason they do that is because water will actually run uphill. So if you put that little bit of a lip there, it kind of pushes the water away from the edge a little bit farther and allows it to drip off away from the fascia board. So just another added layer of protection. I've got a slide here also of the rake edge there, a little more description on how far apart your nails are and the reasoning why you do certain things. Like on this picture here, it shows the drip edge underneath the ice and water shield, and then the raker edge on top. And it's the same kind of principle as your shingles. You want the water to shed away, so the water is going to hit the raker edge first, and then it's going to run down. It's not going to run underneath the ice and water shield. It's got to run on top so that it can be shed away from the roof, and there's no chance of it getting underneath. I also have a video here of installing the drip edge and eave protection.
Metal or plastic drip edge material nailed every 12 inches may be applied to protect wooden edges from damage and to facilitate water runoff into the eaves trough. Note that ICO's Pro 4 roofing system recommends that, along with ICO shingles, accessory items be utilized to ensure the roof performs to its maximum capacity. Eave protection and underlayment are recommended components to the multi-layered system.
Yeah, and as I said before, it's a multi-layered system. You've got your eave protection, you have your raker and your drip edge. You've also got a lot of roof membranes that are available. Basically, the idea behind that is to give it an extra layer of protection so that if something were to happen, if you have a driving rain and some moisture got underneath your shingles, because it can happen, you can have some pretty severe winds and snow and some weather here in Canada. So as much as we can do to prevent any water from getting underneath the shingles, the better. So with the roof membranes, we typically put an ice and water shield along the bottom edge of the roof, and that protects from, in the freeze-thaw cycles, or even if you have a bit of ice damming on your roof, there's a couple things that can happen. You might have issues with your insulation, so if you're re-roofing a roof, you want to look into that before you just put on a bunch of ice and water shield, because it's not really solving the problem. But some parts of Canada, you get a lot of freeze-thaw, and there's nothing you can do about it. It's just something that's going to happen, and that's why we use ice and water shield. And you typically use it along that bottom edge where it is a colder section of the roof because you're not inside the building. It's on the outside edge of the building. If you have a low sloped roof, you run into other issues with having, maybe you might want to protect that a little bit more. But again, like I said before, you want to contact your building official, your tribal council, housing advisor, just to make sure that you're putting enough or you're not putting too much on there. Then your roofing underlayment is just another added protection, like I said before. I think I've got a video here of the roof membranes being installed.
Ideal protection, ice and water protector should extend up the roof 24 inches from the inside face of the exterior wall and over the drip edging. However, it is recommended to check your local building codes, as it may require the ice and water protector to extend further up the roof. Ice dams form when melted snow runs down the roof to the eaves and freezes again, which forces water back up underneath the shingles. Eave protection carries any water which backs up through the shingle to the gutter. To apply Storm Shield and Armor Guard ice and water protectors, cut the membrane into 10-foot to 15-foot lengths. Unroll and align with the lower edge of the roof and tack the top edge with 4 equally spaced temporary fasteners. Lift the lower half and remove the lower release film, exposing the adhesive surface. Carefully reposition the membrane down onto the deck and press firmly in place. Avoid wrinkles. Remove temporary fasteners. Fold the top half down and remove the release film. Carefully reposition the membrane up onto the deck and press firmly in place. To apply Gold Shield ice and water protector, cut the membrane into 10-foot to 15-foot lengths and re-roll. Carefully slit the release paper on a 45-degree angle. Fold back the release paper, exposing the adhesive backing. This corner will be used to hold the material in place as you begin installation. Unroll the next piece of material, ensuring that there is an overlap of 3.5 inches. Do not remove release film at this time. Unroll 3 to 6 feet of the membrane. Carefully slit the release paper at the top of the roll. Do not cut through the membrane. Peel back approximately 6 inches of the release paper to expose the adhesive. Peel the release paper in the opposite direction that you are applying the membrane. Pull the release paper in the direction that you are applying the membrane, applying pressure to the membrane as you proceed. The membrane will adhere to the deck. Once you have finished laying the membrane, go back to the beginning of the roll and pull off the release paper at that end. Next, install the underlayment, overlapping the ice and water protector by 4 inches. Please note that a felt or synthetic underlayment, or equivalent, is strongly recommended beneath fiberglass shingles applied to slopes below 612. Please refer to the ICO Asphalt Shingle Limited Warranty or the bundle wrappers for further details. Underlayment comes in rolls. It must be unrolled, cut to convenient lengths, and laid out flat until completely relaxed before shingles are applied over it. Use only enough nails or staples to hold each run in place, overlapping the course below by approximately 2 inches, 4 inches for Roof Guard SB or Cool Gray, and ends by 4 inches. Never use a piece less than 6 feet in length. Underlayment should overlap hips and ridges by 6 inches, and approximately 4-inch extensions should be left at the chimney and any vertical projection from the roof surface. Apply metal drip edges over the underlayment at the rake edges.
There's some pretty good tips there. I know this is one manufacturer who's showing how to install their products. There's a lot of different products available out there. And each one of them is going to have their own way that they've tested and built their products. So it's important to make sure that you follow the directions that they have so that you can make sure that your roof is installed correctly. Yeah, if you want to be able to get a warranty or anything like that too, they're going to want you to document a few things throughout the process. So it's just important to follow their directions. I know the peel and stick. I've installed the peel and stick before, and it takes a bit of time to get familiar with it because you can end up with the sheet wrapped around yourself and it's stuck to yourself, and it can be a real pain in the butt. But once you get a system down that works for you, by taking in all the different information you can gather from someone who's got experience doing it, or even just watching someone else do it, or watching a video like this, can kind of give you some pointers that maybe you didn't think about when you were installing it. Some of the specialty flashings I'd like to talk about here as well are plumbing vents and some of the issues that you might have installing them and making sure that they're done properly. A lot of times what I see in our communities, because they're sent up through winter road or on a plane, they get sometimes crammed into the plane and they're bent or just kind of missed. They're not a very, they've been stored in a way where maybe they're deformed, and you've got to do the best job you can at trying to get it to the shape it should be. A flat surface is the best because you don't want to have any ripples or anything like that, or anywhere where you could have any issues with it curling or things like that, where you could have water get into it. So I've got a picture here that kind of explains where your ideal space is, where you're going to have your flashing installed. I know in one of our videos from the 2019 Builders Challenge, Jan Eeks had explained how to lay a bead of silicone, or not silicone, but roofing cement for a chimney. And it's a pretty good tip. Like you run that down, you run your collar over top of the pipe, then you mark it, and then you bring it up, and you actually put a bead of silicone underneath the edge so that when you bring it back down over top of it, you're sealing it from underneath and not just the top, because that top layer of caulking is going to wear out over time, and it's something that you have to kind of keep an eye on, because you can have issues with leaks around the vent stacks or chimneys or anything like that. So little tips like that can really be helpful. You also want to make sure that your shingles aren't too tight to the edge of that collar as well, because you need to allow for expansion, and you gotta have proper caulking around there too. So, and it's also good to be able to inspect that as well. So if we're going to go over the factory built chimneys, exhaust vents. This is a picture of on your left, that's an attic vent. This was a vent that wasn't installed properly. You can see it's deformed on the side. The shingles are too tight. It could have been installed maybe in the wintertime or when it was cooler weather. And then now if you see the picture, it could have been warmer. So the shingles have actually moved and actually crushed that. That's why you leave that space. And typically on these types of vents, they actually have a mark that's on there that tells you where to bring your shingles up to. So again, like it's important to follow their manufacturer's instructions. There's also no caulking on the bottom of those nails, so potentially you could have a leak there as well. This other plumbing vent on the right-hand side is a vent for a metal roof. And they kind of look funny because you're not tucking it underneath the roof. You're actually laying in it a bead of caulking and then screwing it down and bending it to the shape of the roof. But they also have instructions on how thick of a bead of caulking you're going to use as well, to ensure that it's tight to the surface and you're not going to have any leaks around that. I like to check these every once in a while too, to make sure that the caulking hasn't dried out or cracked, especially on the top leading edge. Just to ensure that you're not going to have any leaks later on down the road. You also want to make sure that you have your shingles overlapping enough of the flashing. If it's a pre-made flashing for plumbing, like I know I showed the one there for a metal roof, but if it's for a shingled roof, you want to make sure you're not too far down and you're not too far up, because they're going to have any of the flashings that are pre-made that you buy will have some sort of a mark on it that will tell you to bring your shingles down to a certain point or not beyond this point. So it's just a really good idea to make sure you familiarize yourself with some of those parts of your roof, your flashings, your chimney flashings. I know we had done a chimney flashing, like I said before, with Jan Eeks at one of our builders challenges, and it was good to see. It's always nice to have that visual of seeing someone put it together. And any of the manufacturers, a lot of them now are kind of getting to a point where they're starting to show that. They're starting to show how they want their products installed. Because I mean, not everybody can read a set of instructions and fully understand. Sometimes people need to have that visual aid to help and kind of give you that aha moment, like that makes way more sense actually seeing someone do it, or seeing, a picture of it being done with some explanation. It goes a lot farther than just talking about it or reading it as well. I know I'm a visual learner, so that's why I like to show pictures. So I'm talking about plumbing vents, you can actually see what I'm talking about, or an attic vent. The other thing too is some of these vents and these specialty flashings, like if you're looking at an attic vent or an exhaust vent for a roof, you want to make sure that if you have a lower sloped roof, that vent that I showed you on the last slide there that wasn't installed properly, on a low slope roof, I find those don't work very well, because anytime you get any snow on them, they're plugged up, because the snow kind of accumulates around them. And The other thing that can happen too is you're dumping a lot of heat right on the roof. So like if you have the option to put a ridge vent in or even a gable end vent for the attic, that's probably your best option. You also have to make sure you talk to your building, someone who understands building code too, because there is a calculation for how much venting you need on the bottom of your roof to the top of your roof. Because I've seen issues where you'll have actually a lot of heat coming out if you don't have enough of these attic vents, and it'll start to curl the shingles because it's starting to damage, or it's actually ice damming up underneath there and damaging the roof decking or even the shingles. So it's really important to just pay attention. I've seen them where they're a bit of a gooseneck, where they're higher. So it's getting the air away from the roof instead of dumping it right onto the roof and melting and causing ice dams. So you just have to be really careful and mindful of that. I wanted to talk about cricket and saddle flashings. It's something you can either have pre-made depending on the type of roof or metal, like a roofing that you're doing, that you're installing. What a cricket or a saddle is, if you have a chimney. I know before I showed a picture of a chimney protruding from a roof, and it just had a continuous flashing at the base of it. Well, the issue with that is all the water is being directed straight at that flashing. If you ever have an issue with that flashing, or if there's enough water, it'll actually run up higher. And let's say someone didn't seal that joint between the top of the flashing and your air barrier or your waterproof membrane, or if it's an older house and they didn't have those products, it's actually getting up underneath. So what the cricket does is it's like a little hip roof, or a hip roof with two valleys on either side that shed the water and push it away from the edge of that roof protrusion. And you can use them in a bunch of different areas. I know I had shown a picture of a cricket or a saddle that was installed just up against a chimney, but you might have a roof where you have a valley that intersects in the side of a roof, or a wall that protrudes from the edge of from the roof. So you might have to add like a little bit of a cricket or a little bit of a saddle, something that's there to direct the water away from that wall. Anything you can do to get it a large amount of water, like the end of a valley, away from the wall, is gonna just be an added protection to make sure that no water is getting up inside the building anywhere. Okay, so I'm told the image is up. I'm not getting it, so maybe there's something wrong with my internet. So yeah, with the cricket, if you can see the cricket image there, you'll get an idea of what I'm talking about. It's just something to shed the water away from that roof, or that chimney that's coming up from the roof. So those are important also, because if you have, in the picture I put on there, it's a metal roof, but if you have ice or a lot of snow sliding down and hitting that chimney, if that's a masonry chimney, that can be a huge problem, because that could actually push that masonry right away from the house. It'll kind of break that ice slide, and it'll push it away from that chimney and stop any damage that could be unnecessary to that roof. I think we're ready to run some polls here. So the first one I had here, Chris, if you're ready. Just what type of roofing material do you normally use in your community, or whatever part of Canada you're from? I see more people so far using asphalt shingles. A few are using metal roofing. I like both. I think both work really well if they're installed properly. Metal roofing definitely has its advantages. Shingles usually have a lifespan of 25, 35, 45 years, depending on the type of shingle you buy. And sometimes they don't last that long because of other issues. Like you might have a house that's south facing that gets a lot of sun, and it can really damage the shingles. Where a metal roof, you typically don't have that as an issue. The only time you can have an issue is if I know there's been some warranty issues with some of the screws being used, the washers wear out and you can have issues. So it's not like it's not necessarily a, you're going to have to do some work. You're going to have to do some inspections to make sure that you're not having any issues. So we've got another poll here too. And from wherever you are, what type of valleys do you prefer or do you normally see? So we've got open, closed, or woven valleys. Seems to be a pretty good mixture of open and closed. Not too many woven, but you do see them, and it does work. We got a tie for open and closed. Well, that's good to see. Yeah, it all depends. Like with the open and closed, like I said at the beginning, I like to see the closed with the straight line there. It kind of gives the water direction. It's aesthetically pleasing, and the open valley looks pretty nice too. You can kind of match your flashing to whatever color your roof is going to be, and it all depends on what you like, and also too where you are in Canada makes a big difference to what type of valley you're going to have too. If you have a lot of wind, you might not want to have an open valley because the chance of the wind catching the edge of the shingle and peeling it up could be higher if you typically have higher winds. All right, we'll go on to the next one. So, yeah, next question is if you've ever installed a roof. We've got a pretty good mix here. So hopefully this information is valuable to people who have or who haven't either. If you're a housing coordinator and you're looking to order materials, or if you're someone who's installed and you need help with new products that come out and just understanding what they're called to, because I used to I do carpentry, and I know going to school and learning about the terminology is a lot different than on site and what people call certain things. Like on site, we'd call a lintel a header, and in school you have to call it a lintel because you wouldn't get the mark if you put a header on the test. But on site, it can be a little different. So you just have to understand both. What you're going to call it on site is going to be a little different than what you name something when you're ordering materials. So I have one more question here for the poll, and anybody who's ever worked on a roof or who hasn't worked on a roof, do you have fall arrest training? We're not trying to get anybody in trouble here. We're just interested. It's something that if you are a housing coordinator, it might be worth looking into for not only the roofers, but anybody doing anything over 6 feet. It's just a good idea to have that training. It's health and safety, and you can prevent a fall, or the person working on the roof understands what they need to be prepared for the job that they're doing. I an uncle who had fallen off a roof 3 times, and it's not fun seeing what he's had to go through, because he actually broke his back. He didn't. He can still walk, but you know, his spine has fused, and probably going back and showing him what he could have done to prevent that, he would have changed his attitude towards wearing a harness, or, you know, understanding what you need when you're working on heights. It's definitely changed my attitude. I know I had a guy I worked for who we were sheeting a roof, and he said, "Oh no, it's not that steep of a roof. We don't need harnesses." And I was working with my brother at the time, and we told him we wouldn't go to work unless we had harnesses, because we had seen what my uncle had gone through, and the challenges he had with the injury that didn't just last a few weeks or months. It lasted the rest of his lifetime. So, and the next day we both had harnesses. We were on the roof, and then we actually, the guy I was working for stepped on some sawdust, and he refused to wear a harness, and my brother ended up grabbing him by his tool belt because he stepped on the sawdust. And anybody who's worked on a roof, sawdust is very slippery on a sheeted roof without shingles or anything like that. So it's just kind of cemented in the idea to him that needing a harness on a roof is important, whether it's a 412 or a flat roof or anything. It's very important to have. So I think I'm going to open up the questions, and I'll get, hopefully everybody's got a few questions they want to ask. And
good morning, Andrew. We have opened up the chat box in the lower right-hand corner of the screen. If anybody has a question, please feel free to type it in the chat box, and we'll get that off to Andrew. We'd also love to have you ask your questions live with your microphone and camera. If you would like to come and ask Andrew a question regarding today's webinar, please just raise your hand. At the bottom of your screen, you'll see a little blue circle with a hand in it. Just click that and we'll bring you on screen, and you can speak one-on-one with Andrew and have your questions all answered. Now, Andrew, we have received a question a little bit earlier on in the webinar, and one of the questions that came in is, how do I know if my flashing needs to be replaced?
That's a really good question. So, like, if you're re-roofing or you're inspecting your roof, you want to make sure that there aren't any tears or rips, or the hole that you'd be re-nailing it to isn't oblong or damaged or in any way. Typically on a re-roof, your plumbing vent stacks get replaced, your attic vents get replaced. They're plastic. They're not meant to last forever. Typically they're designed to last for as long as your roof lasts. Yeah, so I say, like, inspection. I mean, I'm not telling everybody to get up on the roof to look at it. You can use something like a pair of binoculars to have a look. But if you are re-roofing and you're roofing, like a roofing contractor or someone in the community who's doing shingle work, it's just a good idea to get up there and have a look and use some common sense too. If you see that something else hasn't been installed properly and there's damage and there's rot, that's another indication that the flashing has probably failed and needs to be replaced.
All right, we have a question coming in by chat. While we're waiting for that question to come in, Andrew, another question we have here is, can I use silicone-based caulking on a roof? If so, if not, why not?
Another good question. I actually brought a tube of caulking that I have at my house, and it's specifically designed for roofing. It is an asphalt fiberglass reinforced cement, and the reason you don't use something that's not designed for a roof, I'm not saying you can't use anything that has silicone in it, but you don't want to just use your kitchen and bath silicone, because it's not designed to take the heat and the cold that you'd have on a roof, also the UV rays from the sun hitting the roof. You want something that's designed to expand and contract similarly to whether you have a metal roof or you have an asphalt shingle roof. And that's where, like I stressed before, you're going to have similar products to your shingles that you're going to have. If you have a certain brand of shingle, you're going to have a certain brand that you use for your ice and water shield and your felt paper. Also your vents too. You want to make sure that you're matching those materials together, because you don't want to go up there and do all the work and put the wrong silicone and only have it last you a couple months, and then you've got a leak and everything you've done, needs to be fixed or repaired.
Thanks for that, Andrew. We have a question from Jason. Jason would like to know, what if you were doing an old roof and there is no underlayment or flashing on it? Do you have to put those in when you are redoing the roof?
Yes, I would do that. I would install the underlayment and flashings and everything. It's going to protect the roof. I've seen a lot of roofs where there wasn't flashing or drip edges put in place, and the fascia board's completely rotten. Sometimes the Eave is damaged as well. So I would suggest anytime you do it, and again, you want to follow the manufacturer's instructions. So if the shingle brand that you're using tells you to use that, it just gives, like I said before, it gives you that added assurance that if something were to happen, it's not going to cause rot or damage, because when you get into rot, it creates a bigger issue. It's not just a re-roof, it's a rebuild now, right?
Excellent. Thanks, Andrew. We have a question from Sarah. Sarah would like to know, how can you protect your air barrier when replacing flashing and other parts of the roof?
So can we bring Sarah up onto the screen here? Is she okay with that? Okay. So
just a sec, Andrew. We're gonna try. Oh no, she said no. I'm sorry.
Yeah, no, that's fine. That's fair. So if we're talking a new build, you want to you're like I said in another picture there. You've got a flashing that comes up. You've got like a peel and stick membrane. You could use a blue skin, or you could use something that is designed for roofing. They've got a lot of peel and stick products out there for roofing. And then you put your air barrier over top of that, because then when you nail through that air barrier, it's self-sealing in behind it if you're putting your siding on, and that would protect your air barrier by having it self-sealing. So you're not just putting a bunch of extra holes through it. I hope that answered your question.
We hope so. Sarah, please feel to follow up if you have more questions. We have our friend Jonathan Gregg with us this morning, Andrew, and Jonathan would like to know, what are the venting requirements for roofs?
Let's bring Jonathan up here, because I don't have my building code book in front of me, and I know he's an expert. So if he's willing to come up here on camera.
And we're going to ask Jonathan to join us.
He's testing me, and I know that.
Hey, Jonathan, good morning.
That's good, though. I've got a number. Hey, Jonathan, how's it going?
Good. Can you hear me?
I can hear you, yeah.
Okay. So for venting requirements, yes, I am testing you. But one of the things that we always get a question is, because when First Nations, when they get a home package, there's usually extra roof vents, and there's soffit venting most of the time, right? Yeah. So when you do the calculation from the building code, I'm not going to get into numbers, but just a simple thing. If you have vented soffit, there is enough venting from the vented soffit alone. But the building code requires that 25% of the required vented area, based on the footprint of your house, you need 25% in the upper area of the roof. That's how it's listed in the code. So there is a calculation there how to do it. generally, it's hard to say because there's new products out there now. And why I'm asking you the question is that the new products now, they are larger and they almost look like a beehive if you've seen some of them. And some of those ones, they say they can vent up to 800 square feet or 1,000 square feet, right? But you just still have to make sure that you are still putting enough of those, especially if you get around the 12 to 1,500 square foot. You always want to make sure that your venting requirements are met. And it's a simple calculation, but, and then you also, the notion of putting in those gable end roofs, if you put 1 or 2 in, sometimes based on the size, those don't meet the 25% requirement. And another safe thing that a lot of people do is they use the ridge vent, and sometimes you don't need as much as you think. People generally go right across the whole peak of the roof, and you don't generally need all that. And typical what I found, on a 1,200 square foot house, you need roughly between 10 to 15 feet of ridge vent on top, if you do a calculation. So just some stuff on that kind of stuff. And so there's maximum venting and that kind of stuff. So as all you people listening up there, talk to people like Andrew, myself, other people, your building inspector, and make sure you talk about the required venting, which is, I think, is a maximum, and make sure that you have the 25% in the upper portion. And also now with the blow-in, you have all those stops now with the raised heel. There's just particular details that you want to pay attention, making sure that you have that nice airspace going across from your soffit up to the portion so you get that airflow to reduce your ice dam. And I'm sure I missed part of the presentation, but I know Andrew covered a lot of that stuff in the beginning. So there you go.
That's awesome. Thank you, Jonathan.
Good job.
The other issue I've seen with those gable end vents is you can have a lot of wind washing with insulation. It can add a lot of extra outdoor contaminants like dirt. I know a couple of communities, if you don't have like asphalt roads or you get a really dry spell, you can have a lot of dirt picked up, and it actually pushes it right inside the attic and weighs down the insulation, and it can affect the R value too. So a lot of things to consider there. And like Jonathan said, that's why, we're here to answer these kind of questions.
Well, excellent, Andrew. Thank you very much for your presentation this afternoon. It was very interesting. Of course, people can reach out to the First Nations housing community if they would like more information about today's topic, or if they'd like to connect with Andrew. I'd like to thank everyone for joining us here today. And of course, we would like to hear from you. If you do have any ideas for any new topics that we can cover in upcoming webinars, please send your information through to the First Nation housing community through our various channels via email, off the website, or you could also communicate with us on Facebook at facebook.com/FNHCOM, COMM. After today's webinar, Andrew will be redirected to a survey. We'd love to hear your opinions and what you have to say about today's event, as well as any future events that are coming up. Please remember there will be another webinar next Wednesday. Please check on the the First Nation Housing Community.com website for more information about the upcoming webinar and to register there. Please subscribe online for news and updates. You'll get those updates sent directly to your inbox. Andrew, we're going to turn it back to you to say goodbye, and we'll see everybody again next Wednesday right here at the First Nations Housing Community Webinar Series.
I'd like to thank everybody who participated in this week's webinar. We look forward to doing more of these and taking all your suggestions. It means a lot to us, and means that we're gearing these webinars to what you're looking for. Until next time, hopefully I get to do a few more of these. That'd be great. We'll see you later. Thank you.